Hello everybody, we are ready to do another set of notes, so I need you to go ahead and flip to Unit 3. And it looks like we are doing our second set of notes, and these are going to be on page 30. And the title of these notes are going to be Key Features of Absolute Value Graphs. So key features of absolute value graphs. So basically what that means is we're going to be looking at the graphs and then talking about specific things about the graphs. So you should have either been given a set of notes or maybe you printed them off, but here they are. So you will need to take these, fold them in half, and then tape them down onto page 30. So go ahead and get that done now for me. Okay, so your notes should be taped in. So we are going to talk about absolute value graphs and what they look like in general before we start talking about the key features. So absolute value graphs, they look like every time you see them, every time you have to graph them, they end up looking like the same letter, all of them. It might be different versions, but it's the same letter. So one of the graphs could look like that, which is a V. The other one is going to look like this, which is just an upside down V. So every single absolute value graph that we see, they're going to take the shape of one of those two graphs. And a good way that you can remember this is absolute value. If we look at those letters, so we have value, which is a V anyways, but then if we look at an A, it's an upside down V basically. So use the words absolute value to help you remember what the graphs actually look like. Okay? So now we're going to move on and talk about the parent function. So we're actually going to graph this one. The rest of these examples, the graphs are already done for you, so you're only focusing on key features, but I want you to graph one just to kind of see what it's like. So the parent function. A lot of kids get weirded out and confused by the word parent. This phrase parent function just means that this is the easiest, this is the main function of that function family. So when we go to compare graphs, we're always comparing back to this one, okay? So we're just gonna go ahead and start. We have an XY table right here, X values. We're gonna take these X values and plug it into our equation to get out the Y values. And then once we do that, we'll have ordered pairs to graph. So remember, f of x just took the place of y. It's the same thing. So what I'm going to do is I'm going to take that x value, -2, and I'm going to plug it in that x spot up there. So I'm going to do it on a Post-it note because I didn't make enough space. So you just watch and pay attention with me. So if we have f of x is equal to, I'm going to take my absolute value, but instead of using that x, I'm going to plug in a -2 instead. Absolute value of -2 is +2. Then I'm going to do the same thing with -1. Absolute value of -1 is a +1. Do the same thing with 0. So the absolute value of 0 is just 0. The absolute value of +1 is 1. And the absolute value of +2 is +2. So remember, absolute value, talks about the distance from 0. So anytime we talk about absolute value, when it's the parent function, all these are going to be positive for us when it's the parent function. So now what we can do is take these ordered pairs that we have in our XY table and then use them to plot points on our graph. So we're just going to start. I'm going to start at the very top and I'm just going to work my way down. So -2, 2. And remember, x values come first in an ordered pair, so we're going to go to -2 up to +2. Next one is -1, 1. Got 0, 0, which is the origin. 1, 1, and then 2, 2. And if we wanted to, we could keep going. And you can kind of already see the shape that this graph is going or making. And if we wanted to, we could just continue out placing these points, but we have enough to make a graph. So take a straight edge and you're going to draw a straight line from the dots. I always start, so when I'm drawing absolute value graphs, I always start at the vertex or the middle point of the graph. So go to the middle of the V and then draw your graph. So I'm gonna draw this side real quick. And we put arrows on the end because these graphs are also continuous. They go on forever. Okay, so there's the graph of it. So I'll give you a couple seconds to catch up. Okay, so now that our graph is done, we can actually start talking about the key features. Now, in Algebra 1, there are a few key features that we need to discuss and talk about. So, the first one being the vertex, okay? So I kind of mentioned it earlier when I was actually drawing the graph, but the vertex is the very middle point of the graph. So in this case, since this is a V, the vertex being the very middle, you just find the middle of the graph or the middle of the V, and then you list out that ordered pair. So the vertex is always going to be an ordered pair. So if we look at this one, this right here is our vertex or the middle of the graph, and that is the point 0, 0. And you have to, when you are writing out the vertex, it has to be in parentheses because it's an ordered pair. If you don't put in parentheses, then you're just listing out numbers, okay? The next thing is we have to talk about, is that vertex a maximum or minimum point of the graph? So this question right here depends on the way that the graph is facing, okay? So this graph, which I'll go ahead and talk about the direction of opening first, and then we'll talk about this. So the direction of opening, super quick and easy question to answer. It just means, does it open up or down? So that's pretty straightforward. So this one, the arrows are pointing up, so this one is opening up. So since we know that this graph is opening up, now we can specifically talk about this vertex. Since this is pointing up and the graph is opening up, that means this is the bottom of our graph. And bottom relates to a minimum value, okay? So this vertex is a minimum. So I've had students over the years, they tell me how they remember it. One of my past students told me that they think about this as like a bowl, even though it doesn't quite look like a bowl. Since it's opening up, they imagine a bowl, and this is the bottom of the bowl. Okay? And the way that I remember maximum, and this is how I tell my students, if the graph is upside down, then it's going to look like this. So the direction of opening would be down, so it's opening upside down. This would be our vertex, and this is the maximum point of the graph, because think about it. If this is a mountain and you go to the top, you are the maximum height of the mountain, okay? So focus on which direction that the graph is opening to answer this maximum or minimum value question. So we took care of vertex, the direction of opening. The next thing is called the axis of symmetry, okay? The word symmetry, you learn it back in elementary school, but the word symmetry actually means that if we cut something in half, it is the same on both sides. So a lot of times people in elementary school, they'll have you take a piece of paper and fold it in half, and then when you open it back up, this line right here, the crease, is your symmetry line, okay? Same idea here. If I were to take this graph and fold it in half, so we gotta imagine that I'm trying to fold it in half. We have to pick where's the halfway point of this graph, and then what's the line that's gonna be my crease when I go to fold it. We're not actually gonna fold this, but we're gonna use our imagination. If I were to fold this graph in half, this right here would be the line that I would fold it on. That pink dotted line that I just drew. That would be my line that I folded it on. So when we talk about vertical lines like that, the equation of a vertical line is always x equals, and then whatever number that it's on. So if we look, it's an x value number, so this is gonna be, that's 0. So x equals 0 is our axis of symmetry. That's the line that we would fold it in half on, okay? So axis of symmetry is pretty simple to identify. You're just finding the number that when you fold it, it would cut it in half. but you have to have x equals in front of it. That's the part that a lot of kids miss. Okay? The next part are zeros, and I want to add a little note under zeros, so I left this a blank. The zeros, and in parentheses, I want you to put where the graph crosses the x-axis. So zeros are where the graph crosses the x-axis. So the word crosses, that could mean touches, intersects, whatever you want to use. So zeros are where the graph crosses the x-axis. So if we look back at the graph that we're talking about, we want to know, when does this graph cross the x-axis or touch the x-axis? It only does it one time and is right here. And this is the origin. So we only touch it one time, and that's at 0. If it didn't touch it at all, because I have this question a lot. So if it didn't touch it at all, and it looked like this, so this was our x-axis and this was our y, and it doesn't touch the x-axis at all, you would need to write no zeros. Okay? Be careful on that one. Okay? The last two things are called domain and range, and we've talked about domain and range, but we haven't applied it to a graph that looks like this. So domain, remember, is x values, range is y values. So domain, when it asks what is the domain, that question could also be worded, what are the x values that are used to make this graph? So if we look at these x values, all right here, they're on the x-axis, okay? We also have them over here in our XY table. We have just the ones right here, but everywhere the graph is, that means that we have used an x value. So like this one right here, this one is a +3. The graph was, that x value was used to make the graph. So was 4, so was 5, so was 6. The thing is, this arrow goes on forever in the right direction, so we're gonna keep moving right forever. And then on the left side, we're going to continue to use these points or these x values. This arrow goes on forever left. So we actually are going to use every single number to the right and to the left. All of them. We're going to use all of them. So whenever you see this, there's a phrase. It's called all real numbers, but there's also a symbol. So I want you to look at this symbol. It's an R with an extra line in it. And that symbol stands for all real numbers. So whenever you're asked what the domain is, if it ends up being all real numbers, so that means it continues on forever left and right, you do not have to write out the phrase all real numbers. You can just give me that symbol and I'll know what you're talking about. Okay? And now the range is our y values. So the question again, what y values are used to create this graph? So here in our XY table, these are our y values. And on the graph, this is the bottom of our graph, and I'm going to use everything above it. Notice that none of the graph is down here. So this is what makes range very different from domain. We can't use all real numbers for the range because the graph doesn't go down, it only goes up. So we have to figure out where the graph starts. So before we do that, I want you to write y for the range because we are dealing with our y values. And then I want you to watch closely at the graph. We have to figure out the starting point for this graph. So the starting point is going to be where the vertex is. So I'm just going to draw a horizontal line right here at the vertex because that's going to tell me and make it easier for me to see where the graph actually quote unquote starts. So that number right here, and remember these are y values. So what number on the y-axis is that yellow line at? This is 0 on the y-axis. So I want you to, down here on the range, we already have our y. I want you to put a 0 and then leave a space in between. The space is going to be an inequality symbol, and it's super important. So we have 4 inequality symbols. We can have less than or equal to, greater than or equal to, or less than or greater than. Okay? We have to decide which inequality is going to go in that spot right there. So again, it all is based on the graph. So we're going to look at this graph. And here's how I think about it. I just drew that yellow line, and I'm going to ask myself, is the graph above that line or below that line? So it kind of ties back into what we did when we were graphing inequalities. Greater than goes with above, less than goes with below. So since this graph is greater than, I'm going to use the greater than. But then let's check to see if we can use the or equal to. So if we can use the or equal to, that means that there actually is a point or dot sitting on that number. So this is our vertex, so it can be equal to. So here's what we're going to do. We're going to have y is greater than or equal to 0. And when you see that, that just means for every number from here up, we're going to be able to find the graph. We're going to be able to see parts of the graph. Now we're going to flip to the inside and look at the few examples that we have in here. I'm going to work through a couple with you, and then I'm going to let you practice some on your own. So take a look at example number 1. Like I said at the beginning, all of these graphs on the inside have already been done for you. So I want you to really focus on the key features. And if you need to flip back to the front to kind of see what we did, then do so. Not a big deal. Okay? So the first one is our vertex. Remember that our vertex is the very middle point of the graph. So it's the middle of the V. So here's my vertex. I always put a point if I don't actually see one, I put one there. And remember, vertex is always an ordered pair, so I'm going to grab the ordered pair of that dot, so that's going to be 3, 2. Remember, it's an ordered pair, so it has to be in parentheses. So then I need to answer the question of maximum or minimum. And remember, this question ties directly into the direction of opening. This graph is opening up, which means that this vertex is at the bottom of the quote-unquote bowl. Remember, it's at the bottom of the bowl, so this is a minimum. Axis of symmetry is next. So remember, axis of symmetry is the vertical line that would split that graph in half. So vertical lines are always x equals, and then we have to figure out what x value would split that graph in half. So what I like to do is draw just a dashed line, dotted line, for me to actually see where that graph, if I fold it, is going to be folded directly in half. So my little pink line that I drew is right here at 3. So x equals 3 is the vertical line that would cut it in half. Zeros, that's the next one. Remember, zeros are the numbers where the graph crosses or intersects the x-axis. So here's our x-axis, and that graph is sitting up here above it, and these arrows are going up forever. So this one actually does not have any. The graph never touches the x-axis, so there are no zeros. If there were, then we would just list out the numbers. Okay, domain and range. I'm going to get a lot of practice with domain and range because we see that a ton. So domain, remember, are all of the x values that I'm going to use to create this graph. So x values, remember, so focus on the x-axis. If we move out to the left, this arrow continues on for the left, so both are that's the right, my bad. So we're moving out to the right, and this arrow is going to continue to move to the right as well. Now let's look at the left side, my bad. So looking at the left side, if I move to the left on the x-axis, this arrow is going to follow me out here, which means that I'm going to use every number over here to the left. And when we use every number from the left to the right, we're using all real numbers, which can be abbreviated with that symbol. Looks like an R with an extra line in it. I'm going to write all real numbers just in case, because I need you guys to understand that that symbol means all real numbers. Okay, then we got the range. Remember, range is y values. So I have to figure out the starting point of my graph, and that's always where your vertex is. So I'm going to highlight the line, the horizontal line of where my vertex is chilling at. So here's my vertex, and it's sitting at this number 2. Okay? So remember, range is all about y values. So I'm going to have y is something, the number 2, because this is where my vertex is. Now I need to decide, am I going to use a greater than or equal to or less than or equal to? And that depends on how the graph is opening. This one is opening up, so this graph is going to use everything above that yellow line. So I'm going to use greater than or equal to. And I can have an or equal to bar because it can actually be on 2. That's where the vertex is. Okay? Now let's take a look at example number 2. So this is the last one I'm going to help you with, and then I want you to try 3 and 4 on your own. So example 2. The first thing that I want you to notice with example 2 is this graph is now upside down, okay? Everything works exactly the same as far as finding the vertex, talking about domain and range, where are the zeros, that kind of thing. So there's only a couple things that change, and that's the range. The inequality is going to change, and maybe 1 or 2 other things. So vertex, that is the middle point of the graph, the middle of the V. Here it is. I'm going to just put a little point so I can easily see it. And then I just need to list out the vertex, and remember it's an ordered pair. So that ordered pair is sitting at -2, -2. -2, -2. Now we have that max-min question, but that deals with the direction of opening, so let's talk about that. This graph is opening down. It's an upside down absolute value graph, so think about it. This is like a little mountaintop, and you're sitting up here on the mountain. You are on the maximum point of the mountain. This is the max point that you could be for this graph. Axis of symmetry is the line that would split this graph in half. So find the vertex, because the vertex is the middle of the graph. And I'm going to highlight the line that I would fold my graph on if I needed to fold it. So that pink line is where I would fold it if I needed to. And so the equation of that pink line is x equals, and then that number is -2. So if I were to fold the graph at x equals -2, it would give me that pink line, and I would fold it on that pink line. Okay? Next is zeros. That is, where does the graph intersect or cross or touch the x-axis? So here's the x-axis. We need to just see, does the graph touch it? If it does, where? And this graph is actually below the x-axis and does not touch the x-axis. So, again, this one is no zeros. And that's okay. If there is none or are no zeros, you just write that. Okay? Domain and range are next. So domain, what x values are used to create this graph? So domain is, if we move left and right, do we use all of the numbers? Okay, so let's go to the left first. So that's this way. If we move out to the left, this arrow continues on forever with me. So that means I'm going to use everything this way. And if I go to the right, this arrow is going to go with me as I move out to the right, which means I'm going to use everything that way. So if we use everything left and everything right, that is all real numbers. All real numbers. Range is the other one that slightly changes. So the range, let's find the vertex because that's always our starting point. So I drew my little horizontal line for the y value part. That y value is at -2. That's where our vertex is sitting, -2. So I'm going to have y is something -2. And I have to figure out what inequality goes there, and it depends where the graph is. So if this is the line, I'm using everything below that line. So that's going to give me a less than or equal to, because I'm using everything less than -2. Now that we've done 3 examples together, I want you guys to work on examples 3 and 4 over there on the right. Now, example 3 and 4, if you get confused on either one of those, then take a look at examples 1 and 2 because they are very, very similar. And then once you get done with that, then push play and I will make sure that you have the correct answers. So go ahead, pause this video and work those out. As promised, I'm going to show you example 3 and 4 just to make sure that you have everything correct. So, example 3 is very similar to example 2 because both of them open down. And since they open down, that means our vertex is a maximum point. And this vertex is sitting at 2, -1. So then I drew my pink line again, where the middle of the graph would be, and that's at x equals +2. There are no zeros. The domain is all real numbers because if we look at this graph, this one goes down and left, this one goes down and right, so they go left and right forever. And then our range is y is less than or equal to -1 because where I drew that yellow line, that's at -1, and for the graph, it's going to use everything less than that. Okay, let's go look at number 4, example number 4. So example 4 was very much like example number 1. They both opened up, which means the vertex was a minimum. So it was like the bottom of the bowl down here. This vertex, though, is at 0, -3. So 0, -3. So our axis of symmetry is the y-axis, and that's x equals 0 because we didn't move left or right when we originally started this graph. Now the zeros, this is the first one on the inside that we've actually had because all the other ones were no zeros. So when you have zeros, you're looking at the points where they cross the x-axis. So this happens at -3 and at +3. So you just list those out just like that. Domain is all real numbers because we go forever left and forever right. And the range is y is greater than or equal to -3. I got the -3 part because that's where the bottom of the graph is sitting. That's where the vertex is. And I got greater than or equal to because this graph goes up and we're going to use everything above the line that I drew. Good work today. I do have some practice problems for you to do. And if you need to use your notes to get those done, that is completely fine. Good job today.